Hello everyone. So in this video, we will use this graph to write the equation of the polynomial function in factored form. Now in order to write the equation in factored form, we need to identify the x-intercepts of this graph. So the x-intercepts of this graph are -7. So I'll highlight them on the graph. So there is this one here, -7. And then another x-intercept is -4. Now the graph passes through the x-intercept -7, but at -4 the graph bounces back up. And then again the graph crosses the x-axis at 1, so that's the next x-intercept. And then the graph crosses back up again through 4, and then it crosses back again through 7. So we can list these x-intercepts. So the x-intercepts starting from the left side are -7, -4, 1, 4, and 7. Now we'll use these x-intercepts to find the factors that we will need to write the equation in factored form. So from x equals -7, the factor will be x plus 7. And for x-intercept -4, the factor will be x plus 4. And for 1, the factor will be x minus 1. And for 4, the factor will be x minus 4. And for 7, the factor is x minus 7. So there's a very important step you need to understand and memorize. Now the next step is to identify the order for each of these x-intercepts. So order is the exponent for each factor when we write the equation in the factored form. So the order can be identified by the behavior of the graph at each of these x-intercepts. So if the graph passes straight through the x-intercept, then the order for that x-intercept is 1. So in this case, the order for -7 x-intercept is 1 because at -7 the graph passes straight through the x-axis. But at -4 the graph bounces back, so the order at the x-intercept -4 is 2. So there's a very important concept you need to understand and memorize. And at the next x-intercept 1, the graph passes straight through that x-intercept, so the order is 1. And at 4 again it passes straight through that x-intercept, so again the order is 1. And at 7 the graph again passes straight through that x-intercept, so the order is 1. This is the information we need to write the equation of this polynomial in factored form. So we start with an equation in which we assume that the leading coefficient for this polynomial is a. So the first step is to write the equation in the general form. So that will be f where x equals a. So we don't know what the leading coefficient of this polynomial is. So we assume it to be a, and then we write all the factors. So the factors here are, so x plus 7. Now the exponent of x plus 7 is 1. So we don't write or show that exponent 1. And then x plus 4. And for x plus 4, the exponent is 2, which is the order for that x-intercept. And then now we can list the other factors. So x minus 1, x minus 4, and x minus 7. So these are the factors with their respective orders. So now we have to use an exact point on this graph to find the a value, which is the leading coefficient for this polynomial equation. One exact point given in this polynomial function is 6, 6, 5, 0, 0. So this is a point other than the x-intercept. So we already used the x-intercept points to write the factors. So we should use a point other than these x-intercepts. Now we'll sub in this point in this equation to find the a value. So we'll sub in 6 as the x value and sub in 6500 as the function value. So we'll start by writing 6500 on the left side. So we get 6500 equals a times 6 plus 7 and then 6 plus 4 squared times 6 minus 1. So we replace all x's with 6 and then 6 minus 4 and then 6 minus 7. Now we can evaluate the terms in these parentheses. So the left side stays the same. So 6 plus 7 is equal to 13. 6 plus 4 is 10 and 10 square is 100. And then 6 minus 1 is 5. 6 minus 4 is 2. And then 6 minus 7 is negative 1. And in the next step, we can multiply all of these numbers on the right side of this equation. So equals a, I got negative 13,000. Now we have to solve for a. So that means we have to isolate a. So for that we should divide both sides by negative 13,000. So a is being multiplied by negative 13,000. So we have to use the reverse operation of multiplication, which is division. So now the negative 13,000 on the right side cancel each other out. So we are left with 6,500 over negative 13,000 equals a. And we can reduce this fraction to negative 1 over 2 because the denominator is negative. So the final value for a is negative 1 over 2. So now we can use this value of a to write our final answer for the equation of this polynomial function in factored form. So the equation will be f at x equals negative 1 over 2, and then we write all the factors. So x plus 7 times x plus 4 squared x minus 1 x minus 4 times x minus 7. So this should be the final answer for this problem. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.